Alrighty, this will be the first video on our complex numbers topic, or otherwise known as imaginary numbers. So before I launch into actual questions, I want to go over what an imaginary number actually is. So we're familiar with something like, let's say, the square root of 9. And what that says is what number that when I square it, I get 9. And we're trying to find that number. Well, we know the answer to that question is 3, because when I do 3 squared, that's 3 times 3, which gives me 9. But the issue is, if you do minus 3 squared, you get minus 3 times minus 3, which gives you positive 9. So there's actually two answers to this. You get minus 3 and 3. So the square root of 9 technically should be plus 3 or minus 3, just like that. So, well, if 3 squared gives you 9, and minus 3 squared gives you 9, then what happens if I try and find the square root of minus 9? So what number that when I square it, do I get minus 9? Well, think about it. If I square all positive numbers, I'm going to get a positive number. And if I square a negative number, I'm going to get a positive number. So I'm out of numbers. There is no solution. Well, that's what you would say before we know about imaginary numbers. So we invented this number called I, and it is the square root of minus 1. And that is the definition of this number I. And it solves that equation. So depending what mode your calculator is set to, you can try and calculate square root of minus 9, for example. And there we go, non-real answer. So the calculator is not very happy with it. But with I, we might be able to find the answer to this. So if I look at square root of minus 9 and try and figure out what that is, well, that's going to be square root of 9 times minus 1. I can split it up like that, which is root 9 times root of minus 1. We know root 9 is just 3. And root of minus 1, we have a special name for. I call it I. So this is 3i. And that is the square root of minus 9. Pretty cool stuff. So another good definition, I we can define as the square root of minus 1. You could also define it like this, I squared is minus 1. All right, good stuff. So then we have the complex plane. So if I look at the real number line, I've got all my real numbers on it. 0 sitting here, I get 1, 2, 3. I get minus 1, minus 2, and minus 3. So where does I sit on this number line? Well, it doesn't really sit anywhere on the number line. So what we do is we put it right up here. Here's I. Where would 2i sit? Well, 2i sits twice as high. 3i could sit up here. And what you actually get is another line like that. So if this is the real numbers here, then these are the imaginary numbers going up here. So this might be ringing some bells of Cartesian planes, and hopefully it does, because that's basically what this is. So this is 1, 2, and 3. And you can do complex numbers, which are like combinations of these two. So if I look at this point out here, we can see that's got a real bit of 2 and an imaginary bit of 3. I write it in as 2 plus 3i. I could write down a number here, minus 1, take 3i. So the imaginary bit's kind of like your y coordinate, and the real bit is kind of like your x coordinate. So let's do some questions. Z equals 3, take 4i. We want to find the real bit and the imaginary bit. Well, I mean, the real bit is just 3, and the imaginary bit is the number with the I, that's minus 4. And let's just plot it for fun. So I got 1, 2, 3 on the real, and 1, 2, 3 minus 4 on the imaginary. Here's Z, 3 take 4i. Okay, next we've got this thing here, Z equals 2 plus 3i, and W equals minus 1 plus 4i. We're going to find Z plus W. So this actually equals, well, 2 plus 3i plus minus 1 plus 4i. So that first bit's Z and that second bit's W. You just add the real bit, so 2 with minus 1 is going to give you 1. And then 3 and 4 for the imaginary bits will give you 7. Next, we've got those same two numbers, but I'm going to find Z take W. So that's 2 plus 3i take minus 1 plus 4i. So if I do 2 take away minus 1 would be my real bit, and 3 take 4 would be my imaginary bit. So all up, what this gives me is 3 take I. Because 3 take 4 would give you -1, so -1 is the imaginary bit. 2z plus 3w, same numbers again. So this will be 2 bracket 2 plus 3i plus 3, lots of w, so that's -1 plus 4i. Let's see. So this becomes 4 plus 6i when I expand a 2 out into those brackets. And then this becomes -3 plus 12i. So that's 4 take 3 is 1, and 6 and 12 give you 18. 1 plus 18i. Now we also have this thing called the conjugate. And what the conjugate does is it flips the imaginary bit's sign. So if I have z conjugate here, that's going to be 2 take 3i. Now if you already had a take, that would become a plus instead. So if you look at a graph and like here's the number z, usually z conjugate is like flipped on that real axis, just like that. Now z conjugate is normally written as z with a bar over the top, but you can also see it written as z with a little star there. It just depends what you're reading.